All right, here we go again, boys and girls. This is assignment 5B. Again, this will look a little bit different than the last video, but again, this is the same formula setup that you need. So again, when you're doing a table problem, this portion, you follow along with. So these are table problems. So it's like A out of the total is the probability, and is the intersection, or is A plus B minus the and. Again, out of the total. And then given is the only one that isn't out of the total. So again, you'll notice that everything is always out of the total. And again, that's usually the bottom right number, except when you have the word and. And that second piece, the second piece will become the total. And then the intersection, the intersection will become the numerator. And so that is your given problems. So the second piece becomes the total. And then implies that there's two events taking place, this and then that. So if there's two different things taking place, like you draw a first ball and then you draw another ball. Coach Mannix looks for a basketball player and, a person with an A or something like that. And when there's two different things taking place, or an and in general, you multiply the A with the B or the B with the A, the same difference. And a lot of times it has the word given involved, and that's a lot like the basketball player question that we'll be facing, or I guess the drawing balls like marbles from a jar or something. All right, on to the problems. Okay, there are 412 music players, 29 were defective. All right, so let's kind of understand what this is saying. There's 412 total. Of that, 29 were defective. Okay, that would imply that the not defective would be 383. So the probability is, what is your estimate that the probability the new player is defective? So that would be the defectives out of the total. And then part B, what is your estimate that the probability the new player is not defective? So that would be not defective out of the total. And now this last question is either a music player is defective or not. What is the sample space? What is this quote-unquote sample space in this problem? So that's one question. Second part to the question, what do the probabilities assigned to the sample space add up to? All right, so first question is, what is the sample space? What a sample space is what are all of the different outcomes that could potentially happen in the context of this problem? And the things that are possible is that you pick a defective or a not defective. All right? One of those things is going to happen. It's either you get a defective or a not defective. And that, the words are the sample space. Okay, so that's, like part one of the question. What is the sample space? And the sample space is defective and not defective. Second part to the question. What do the probabilities assigned to the sample space add up to? And so I see that the defective was 0.704. The not defective was 9.296. So what do they add up to? One. They add up to 1. I'll kind of write it like this. What do they add up to? 1. So there's 2 parts to that question. What is the sample space? And that's the words. Second part of this question is what do those probabilities assigned to that sample space add up to? Okay, this is the and then problem. So 2 things are taking place, so I multiply the probabilities together. Okay, here we've got balls, and so we have 5 red, 8 green, 4 blue, and that makes a grand total of 17. This first one is with replacement. The second one is not without replacement, and they're both and questions. So that means you multiply the 2 probabilities together. So the first one is drawing a red, and then drawing a green. Okay, so I'm going to do the same thing in this part B. I'm going to do the exact same thing. So I draw a red, and then I draw a green. However, I don't replace that red ball before drawing the second. All right, so here we go. The probability of drawing a red is 5 out of 17. But because I drew that red, that leaves 4 reds and 16 total. 4 reds and 16 total. So I draw a red, and then, so multiply, a green, 8 out of 16. Robert is applying for a bank loan for a piece of franchise. He must complete a written application and the interview. So what is the probability of application and being accepted by the interview? So this is what the question is. So what's the probability of being passed by the written application, and the interview? All right, past records for this show that that probability of being approved on the written application, so the probability of being approved on the written application is 0.57. The probability of being approved by the interview committee, given that the candidate has been approved on the written application, so the probability that they pass the interview, given that they pass the application, is 0.82. What is the probability that Robert is approved on both the written and the interview? And so this is going to be the probability of A times I. Here we go with the table problems. So again, the most important thing for the table problems is understand that the and is the intersection. Or is still an addition, A plus B minus and. Again, sometimes there isn't a minus. And then given A, given B, the second piece becomes the total. And the and is the numerator. So here we go. What's the probability that they are not satisfied? 38. So that's 38 out of the total. Again, the total is usually found in the lower right. Next is the word and. So this is going to be the intersection of not satisfied and walking. So where does not satisfied match up with walking? And so they intersect at 22. Again, out of the total. Okay, here we have the word given. So the second part will become the total, the bottom number. So the referred, erase this junk here. So the referred, the total is 153. And the and is the numerator. So where does it intersect with not satisfied? And it intersects at 6. After that is what is the probability that they are just straight up referred? So that's 153. And then last but not least is the word or. So this would be A plus B minus and. So the first one that we have is not satisfied. So that's 38. A plus B, the TV, is 112. So that's A plus B minus the and, where the two things intersect each other. And they intersect at 10. They intersect at 10 out of the total. And so the top part of that is 38, 112 minus 10 out of 372. A plus B minus and is the word or. Okay, or A plus B minus intersection. All over the total. Let me bring in my deck of cards here. Can help us understand this just a little bit better. Here's my deck of cards, and we are dealing with the word or with these questions. Okay, the word or. Okay, so these are both or questions. And so what ors are is A plus B minus and, the intersection. Sometimes they don't intersect, so just kind of heads up on that. All right, so the first one is a king. So there's 4 of those kings, plus 4 queens. There's 4 of those queens, minus any intersection. Those two things do not intersect. So that's out of 0, minus 0, all out of the total of 52. So that's going to be 8 out of 52, 1538. A plus B minus and. Next, we have an OR problem, which is a 3. So there's 4 of those, plus or a diamond, these bottom ones right here, and there's 13 of those, minus the intersection, and they intersect at the number 1. out of the total. And so that's going to be 16 out of 52, 3077. Last but not least is the law of large numbers, which in essence, we're just supposed to identify what the probability is supposed to be. Heads up, most of the times you're flipping a coin, all right, you're flipping a coin, which there's a heads and there's a tails. And so the probability of that is usually going to be 1/2 unless they change up the probability like somehow. It's either going to be a coin or it's going to be a die or a dice, which there are 6 different outcomes, all 1 apiece, for a grand total of 6. So the probability usually when you're talking about a dice is 1 out of 6. Again, unless you're changing the probability somehow, like in asking something crazy like, what's the probability of getting an even number? An even number. And the probability of getting an even number would be 3 out of 6. But in general, in these problems, if a die is mentioned, you're talking about a probability that is typically 1 out of 6. Okay, that's what the law of large numbers will imply in these situations. Let's take a look at this specific question. You flip a coin 10 times, resulting in 7 heads and 3 tails using the law of large numbers. What would the probability of flipping a head be? Law of large numbers, 1/2.